Hello, everybody. My name is Kevin. I'm the training coordinator here with the Association of State Floodplain Managers. I'd like to welcome you to this quarter's presentation of our Cooperating Technical Partners Information Exchange. Today we'll be talking about FEMA 2D Modeling Integrated Planning Team. But before we get into the topic at hand today, I wanted to go over a few admin items and just kind of calibrate everybody's expectations for what to expect today. So um, number one, we've got a pretty large audience here today, and so we won't be able to communicate, talk back and forth, like have your lines unmuted. But we do want to solicit questions and comments from you throughout. So if you have any questions or comments about anything you see today, go ahead and drop it into the Q&A area of the Zoom interface here. What we'll try to do is save those for a dedicated question and answer period at the end. So if you ask something early on that doesn't get addressed, just try to be patient and we'll take as many questions as we can kind of as time allows. We've got 90 minutes set aside for the whole presentation today with, again, a dedicated Q&A period at the end. So we'll try to address those at that time. Next thing I want to touch on professional credit. So for certified floodplain managers and planners, this is eligible for professional credit. Um, the thing about earning credit for this is you have to join us for the entire duration today, and if you're viewing in a group setting, we won't be able to issue credits to those of you in a group. But suffice it to say, so long as you're with us for the entire duration and you participate, you are eligible to earn credits. We do also have a bit of a knowledge check at the end, and we're going to ask you to rate this webinar at the end of the presentation as well. So look out for that when those pop up on the screen toward the end. A couple other logistical items. One that kind of goes hand in hand with credits, but we will be issuing certificates of attendance for those of you who stay on for the duration as well. It takes about a week, sometimes even a week and a half to turn those around, but we'll email you directly with a PDF attachment of your certificate. So please be on the lookout for that and please be patient. The other thing is, again, this is a quarterly webinar series and we're always interested in hearing from you if you have topic ideas. So you can email Alan. His email address is on the screen there if you have any ideas you think might be appropriate for a presentation within this series. But with that, I want to turn it over to Alan Luloff in our Flood Science Center. He's going to talk a little bit more about the CTP subcommittee, their work, and our presentation today, as well as introduce the speakers. So Alan, please take it away.
Good day. Yeah, my name is Alan Buloff, and I'm with the ASFPM Flood Science Center. And a number of years ago, I think it's 4 years ago now or so, the ASFPM Board of Directors passed a resolution in support of the Cooperating Technical Partner Program. It's an excellent program that FEMA has initiated that really involves state and local entities in their mapping process. We're very supportive of it. And in addition, at that same time, we created a CTP subcommittee, which is a subcommittee under the Mapping and Engineering Standards Committee. And it's co-chaired by Joanna Rolfe with Kansas and Dave Gannett with Maryland. And you can see the major goals we have here. And one of the major things we do is we put on quarterly webinars, which today is one of those. And you can find our past webinars on our ASFPM Flood Science Center website, where the recordings of all the past webinars have been held, and we get very good attendance, and we appreciate you attending today. So you can see the agenda here in front of you. We've covered the admin items and going through the introduction. And today we have Laura Alshu and David Rosa presenting on the 2D Modeling Integrated Planning Team. And Laura is as you can see, she's the National CTP Program Coordinator. And I really appreciate all she has done to kind of promote the CTP program. And with that, I'll pass it off to our speakers today. So thank you.
Great, thanks, Alan. Share my screen. All right. So what we want to talk about, uh, my name is Laura Algio, with the Engineering Services Branch with FEMA headquarters. So I have been working in the CTP program since 1999, basically. So well engaged and part of this group, but also am a professional engineer and have been helping support some of the updates and changes for two-dimensional modeling processes, the floodways, and how those work. And then a few years ago, David Rosa came on board with a strong hydrology background and really pushed the 2D group beyond just looking at some of the floodway components into looking at some of the larger processes and components related to 2D modeling as a whole through the 2D IPT. And we kind of expanded that group. And so that's what we want to talk to you a little bit about is sort of how we ended up where we are today, why the two-dimensional modeling is important, why we're doing this work, what have we done already as part of some of those initial groups that we coordinated with, and changes that we've made to GNS. And so I'll apologize, I shorthanded that. That's guidelines and standards. So the changes that we've made to guidelines and standards already around to incorporate the changes and nuances between two-dimensional and one-dimensional modeling. And then also what the IPT is working on now, so that integrated planning team that Alan mentioned. So why is two-dimensional modeling important? So we started probably in 2016, maybe even like one-offs before that. But in 2016, when RAS was released in 5.0, and so we had a free version from HEC that was able to do two-dimensional modeling. We started seeing much wider use of modeling two-dimensional components for flood hazard studies. We started at FEMA looking at sort of what we called large LSAE, which was approximate studies, large area approximate studies. And so we started doing it in a much broader scope. There wasn't in 2016 as much topography available to really make really good information and decisions for some of the modeling. There were some break lines, not a lot. And we just used some sort of uniform precipitation across the board for hydrology. So it was kind of a low level used to really inform sort of plans going forward. And then in 2018 to 20, we started doing some probabilistic explorations to really try to understand the insights on, as you look at things from a watershed scale, what kind of models are best to try to get a more thorough and comprehensive answer for some of that. And so that leads us kind of to where we are today, which is looking forward and some stuff we'll talk about in a minute related to a program, some explorations called FFRD, Future of Flood Risk Data, as well as base level engineering that we're doing for two-dimensional modeling. With 6.5 out, it's got a lot more capabilities and we see much higher resolution. Better topography is available in many places across the country, which gives us much better answers. The ability to add more break lines and refinement regions, and spatially vary the precipitation and infiltration. So we end up with a lot better answers that can be done with the base level engineering in 2D modeling. As I mentioned, 2016 was when RAS 5 was released. So there were 2D modeling done before that, obviously, but really kind of took off when there was that free model available from the Corps. Sorry. Across 2016 to 2019, we started seeing much more flood studies more broadly being completed and larger watersheds being analyzed. And that's about when the time that this, the idea of this FFRD vision, this future of flood risk data vision was kind of in its infancy with an idea that two-dimensional models would be the baseline for some of that. As we started seeing more and more studies and better quality studies that could be put on a flood insurance rate map, as we moved into using 6.5, 6.2, 3, 4, 5 with more functionality, we really started to see some of the challenges with floodways specifically for two-dimensional modeling. And so that's why in 2019 to 2020, we kicked off the floodway IPT. a lot of our guidance was just contradictory to some of the things that can happen in the two-dimensional modeling world. So we really needed to resolve some of those to make sure that studies that were being done were within the guidelines and standards that we have. So we did do some updates to that I'm going to talk a little bit about, as well as some additional testing. We started discussions with HEC to really try to work with HEC to incorporate some of the FEMA specific components into RAS. In 2021, RAS 6 and 6.0, 6.1 were released. And from this 19 and 20 to 21 timeframe, we had funded HEC to incorporate two-dimensional floodway modules into RAS. So folks didn't have to do them sort of outside of the system. They were and use GIS tools. It could be done within RAS. And so in 2023, that's when 6.4 was released, which had the first of the 2D floodway modules. Those have been enhanced a little bit with 6.5 that recently came out. And so having some of that capability, we really moved on in 2022 to expand the 2D IPT to more than just the floodway issues and looking at broader two-dimensional studies. And then we also initiated some additional testing and evaluation of some of the areas of interest, as well as coordinating with the FFRD pilots and the standard operating procedure that's under development for that, for folks to understand how to do the flood modeling in order to roll into the vision of how we would do that analysis with FFRD. So with that, I'm going to turn it over to Dave Rosa to talk a little bit about FFRD.
Yep. Thank you, Laura. So, right, we're going to spend a little time just talking about the Future of Flood Risk Data Initiative and how 2D modeling is an integral part of that. And then we'll go back to talking about the IPT and the work that we're doing to understand and resolve questions that come up with how 2D modeling fits within the current modeling framework. So it's the future of flood risk data. And so this initiative is really about producing more comprehensive understanding of flood hazard and risk data under current conditions. There is an aspect of this about future conditions, but won't get into that right now. And so I'll just be talking really about how we're improving our understanding of flood hazards and risk as they are today. And I apologize, there's several animations here. Thank you, Laura. So the first objective of the Future of Flood Risk Data Initiative is the shift from a binary to a probabilistic modeling framework. We spent a lot of time really focused on that modeling that 1% annual chance flood inundation map, and that really kind of I guess interpreted as a binary understanding of risk. If you're inside that floodplain, you're at risk. If you're outside that floodplain, you're not at risk. We know that it's more nuanced than that. There's varying levels of risk and hazard within a watershed. And so shifting towards a probabilistic approach that looks at several recurrence intervals and quantifies the uncertainty surrounding those estimates can help us improve our understanding of hazard and risk. The second objective of FFRD is to modernize the way that we store and manage data. And this isn't just about the way that we store or allow facilitate access to the results, but it's also about how we build, store, and facilitate access to the models behind those results. The third objective is that as we produce this, as we modernize our data management and the models and data that we produce, these resources should empower stakeholders like the private sector, CTPs, other state, local, tribal, and territorial entities to have both a role in producing the models and that data, as well as developing and deploying the tools to make decisions. And finally, the fourth objective is increasing this access to rich hazard data would ultimately drive risk-informed mitigation planning and insurance actions. And so together, these four objectives drive a more risk-informed NFIP, and one that really helps work for many types of users and decision makers. Next slide. So I'm going to spend a little bit of time just talking about where we've been and where we're going. And so on the left is going to be where we've been, and on the right is where we're going. And it's in the context of two watersheds. So on the left-hand side, next animation, right? Historically, we've really been focused on 1D modeling, cutting cross sections on various stream reaches, really focused on fluvial sources of flooding. So flooding from streams overflowing their banks, and really concerned with event-based analysis, particularly that 1% annual chance inundation. And you can see that here where it's really focused on a single data point, which is that 1% storm or that 1% flood and the elevations associated with that event. As we shift to the right, so we do sometimes add other data points. Maybe we'll add the 500 year. Maybe we'll add a few other more frequent recurrence intervals to our modeling to try to get a better sense of flood hazard in the area. So on the right is where we're headed and where we're shifting towards with the future flood risk data. So this is two-dimensional watershed-wide modeling. It's using rain-on mesh approaches. So this allows us to quantify both fluvial and pluvial hazard. So not just rivers overflowing their banks, but the flooding that's not necessarily associated with any river or stream, and it's flooding that is in urban areas or from extreme precipitation. And we're doing this in a probabilistic stochastic approach, which helps us to quantify the uncertainties with all of those estimates. So now we're not just focused on single data points on the axes, we're now quantifying a large range of recurrence intervals as well as the uncertainty associated with those estimates. Next slide. So just to talk a little bit about historically what the outputs that we've been focused on the left-hand side, we've really been focused and optimized to produce that flood insurance rate map, as you can see there. So that flood insurance rate map, it's a regulatory product that we produce. It's very binary, you're in or you're out of it, and it's really been the key derivative product. As we shift towards that to the right to that two-dimensional probabilistic approach, one of the things that you can see on that top right is a flood hazard curve. So with this approach, we can get information, as I said, across a large range of recurrence intervals and the uncertainty associated with those estimates. And from that, we can produce graduated outputs to give a better sense of the nuanced and graduated risk that is in any given watershed. And then we can also derive multiple derivative products. We're not just focused on that regulatory product. We're creating data that can be derived for a wealth of products, and that includes next slide, I believe, being able to extract a regulatory boundary where needed, because that median 1% annual chance flood inundation boundary is within that more comprehensive data set that we're producing. Next slide. So just to maybe give it a little bit of a different view, maybe a real world view. So right, this is a view of a historic, regulatory flood insurance rate map. It's pretty binary in nature. You don't really get a great sense of the hazard and risk, other than blue seems to be hazard and nothing not blue is no hazard. So if we shift towards a comprehensive probabilistic approach, a watershed wide scale approach, now we have a much more comprehensive understanding of the flood hazard and risk, and we can start to derive various data sets. We can get hazards like surge and wave, or depth and velocity. We can also start to produce the probability of those depths and velocities occurring anywhere in the watershed to better drive risk-informed decisions. And the 2D approach is really foundational to being able to do this consistently and at scale across the nation. And then I think I turn it over to Laura.
Yeah. So as you've heard, there's been a large uptick in people doing the two-dimensional modeling as the software became easier to utilize, and as we have more topographic data, which really, that ground elevation data really drives the quality of the information. And then as we start to think about the uses and some of the current challenges with the current products that we have, and the messages that we really want people to understand related to their hazard and risk, you can sort of see how this two-dimensional modeling is sort of pushing us forward. So in order to be able to do all the things, the really cool things that Dave just talked about with FFRD, there has to be that sort of two-dimensional base. So the challenge the challenge space we live in is how do we implement our current program with the guidelines and standards that we have today, and also build for that future. So that's sort of what led us to trying to make some of these guidance and standards changes. Some of the first things that we changed back in 2020 were some of the standards. We changed probably a dozen or a baker's dozen of these, but the key ones were really one of the surcharges, one of the SIDs talked about surcharges that are allowed with a modeling component. And we had said no negative surcharges were allowed because in one-dimensional modeling, that means your model is failing. That does not mean that you're failing in a two-dimensional model. So we removed some of that language. We also changed some of the floodway language instead of the language that is used for the equitable distribution of flood hazard as you start to encroach and look at what a floodway what is happening to a floodway in order to get that 1 foot surcharge per the current regulations. That didn't make sense. That type of process didn't make sense with the two-dimensional. So we changed that to equitable consideration. So there's a lot of emphasis on when you do two-dimensional modeling, using depth times velocity as a starting point for your floodway, because that really shows, the depth, the deepest waters, and the velocity, the highest moving waters. So you combine those together with deep, fast moving water, and those are your highest risk areas. But with the floodway constraints per regulation, we also want to make sure that we're equitable from one side of the river to the other. So just cleaning up some language there. And then the two bigger, sorry, it's been like 3 weeks since I was sick. I apologize, but the coughs still just come out of nowhere. And then the two biggest ones are saying removing the requirement for profiles. So with a one-dimensional model, you have to have a profile so that somebody can interpret the base flood elevation to 1/10 of a foot along that profile that's provided in the FIS text. As a part of the SID change, we made it so that you could input an FIS insert. So you can either show the elevations so that at a much higher resolution. So previously we had said BFE placement should be at a whole foot. We have changed that SID to that standard ID to say that you can do up to 1/10 of a foot as a note for your BFE lines. So if you've got enough space on the map, you can replace having to do profiles altogether by just showing your cross sections or your BFE lines close enough. Or you can use a different type of flood insurance insert. So it wouldn't have to be a profile per se, because that wouldn't necessarily make sense, depending on the type of flooding that you're seeing from a particular stream source. So an example you see on the right-hand side is, potentially a grid that you'd be able to overlay on a smaller section in the profile, or to replace the profile in order to kind of determine those base flood elevations at a more refined scale. And then we also, for the floodway, added evaluation lines. That's that SID 75. So basically saying that for those floodways, when you're making the determination, you have to look at no rise, or not more than 1 foot rise at any point, right? So the challenge then with the model is that with a two-dimensional model, you've got that grid spacing that you see in that upper right-hand corner potentially. That's a lot of different components to make sure that they don't change at all, which is very, I won't say impossible, but pretty close to impossible to get to without seeing some changes. And so by using evaluation lines, similar to how cross sections would have been developed, it gives an ability to sort of average some of that in a similar way to what the regulations intended back in the 60s with one-dimensional modeling. So those were kind of the big things. We also updated the guidance documents, obviously, to reference some of those changes from the standards, really making sure that we made references to the floodway data table related to evaluation lines and some of the things that need to be in that floodway data table for a 2D model. Also, down in the floodway analysis and mapping guidance, you can see the definition of the evaluation line, discussion of where you place it, discussion of how you do the setup, initial encroachment screening and encroachment techniques, and how you can look at doing a no-rise with evaluation lines and how that might play out. And then also under the technical guidance, there's more information related to those FIS flood insurance study grid inserts. So looking at, instead of profiles, being able to use these inserts that might replace those profiles as another tool for your local community. So from that, as I mentioned, the IPT as a floodway component began in 2019. In 2022, it grew to all things two-dimensional. And the way we set up the group was really to have a list of topics. We surveyed the entire group, and then we started breaking that group into subgroups. And the way that those subgroups operate is to brainstorm, identify their issues, go to the steering committee to kind of get tasks and next steps green lighted, coming up with a solution and developing recommendations, vetting those recommendations at the full 2D IPT, and then sharing with the broader community once a path forward is identified, to get more feedback from the engineering mapping COP, and then ultimately folding whatever changes need to be made into the guidance and standards, or other components related to the guidance. So this is just a listing of all of the different topics as the charter was initially developed in 2022, June of 22. We had, as you can see, dozens of topics that were highlighted as challenges and concerns that folks are dealing with as they do the two-dimensional modeling. We tried to group those together. The little arrows you can see sort of show some of the interconnections between some of these pieces. So a lot of them can kind of interconnect as you start to work through them. And we ended up with a setup group, a hydrology, a hydraulics, a mapping, a floodway, a products, and a regulating subgroup. We also had a foundational subgroup that Dave will talk a little bit about, that we sort of set the framework for the entire IPT as we kicked off. But these are the main work groups that were underway. So you can kind of see when they started and where they're at here. The overall IPT, as I mentioned, started in June of 22. Foundational subgroup closed itself out and sort of laid the foundation, kind of like we've talked about it as sort of Jersey barriers for the group to keep in mind. The floodway subgroup was reinitiated as part of this in 22, documenting some of the solutioning and some of the remaining technical issues, and then identifying additional guidance and updates that might need to be made for each of those topics. So working through some of those. Products is advancing some testing and recommendations. Mapping has made some recommendation and is awaiting sort of a progression plan for how to move those forward. Hydrology is reviewing recommendations for next steps, and then regulating and hydraulics have just kicked off. So they're still collating some of the feedback from their groups, brainstorming, developing their charters, and getting feedback on the topics that they want to move forward with and the order in which they want to move them forward. And we're going to go, don't worry, we're going to go into all of these in much more detail. That's just sort of the high level. So in order to be successful as these subgroups, we have the subgroups, they meet, brainstorm these ideas, understand any subgroup related needs. So, if they've got a topic that connects to one of the other groups, they need to coordinate with that other group and make sure that they're sharing the feedback for both of those. Identifying those proposed solutions or recommendations, going back to the IPT full group to really talk through potential next steps, and then FEMA and or the group would identify whatever priorities or resources to address and undertake the needs. So if it's just guidance and standards, we can move forward with those. Some of the things that recommendations are tied to involve potential additional testing. So really trying to understand what other things we need to be looking at in order to be able to make a decision to move forward. So FEMA looks at sort of prioritizing those needs and initiating some of that testing to move those through the next steps. So some of that testing that has already been done. So these are titled exploratory contributions. So basically some testings that we've done, you can see the little dots relate to the different subgroups that they support. So there's been a lot of work that has supported some of the needs and discussions that have taken place. So one is model maintenance, how to maintain models. One is related to cell size, understanding, what the best cell size balance is to ensure that the model can run effectively, but also give a good answer as an end result. Bathymetry, understanding the importance of bathymetry in the model and how critical it is. Future floodway. We have a couple recommendations, or not recommendations, but a couple of scenarios that were provided as potentials for a future floodway that were evaluated and looked at. Rain on mesh calibration, also the core pilots that I mentioned as we're looking at FFRD. There are 3 core pilots underway, and so the reporting out for some of those. And then the floodway exploration testing. So for the floodway group, again, since that one started in 2019, there already have been the standard and guidance updates that were made in 2020. As I mentioned, there were 11 standards and 20 guidance documents over the course of 21 and 23 to 23 that those updates were made. We have recently repolled the floodway group to prioritize any remaining technical issues. So we'll be moving forward with that. How to do a no rise was one of the issues that was identified because of the language in the guidance, or in the statute, regulation that says that you can't increase at any point, and with a lot more points as 2D data has evolved. How do we handle that? Some of that was tied to that development of the evaluation line and averaging approach. And we are also currently working with FEMA floodplain management and OCC to see if there's additional ways that we could, additional alternatives to evaluation lines, because those have their limitations as well. So we'll be working through some of that as we move forward to see if there's other options that we have related to that. Defining guidance or best practices around the appropriateness of the different methodologies. So we tested and compared different 2D floodways created with different methodologies, using steady versus unsteady, trying to use raised terrain as a boundary instead of, trying to use high end values as a boundary instead of raised terrain, which is the normal way that floodways are developed. Some of that was done in 2020, and we did some additional testing in 2022 about the high end view values. And then again, we recently repolled, so we've got some other topics on the next slide I'll tell you about. And then some of the concerns around lengthy 2D modeling times and the time-consuming floodway analysis. So we did some research and developed an applied approach that has been posted that will help you hopefully reduce the number of iterations needed. It created a regression equation basically based on certain key values that will help you pick a starting depth times velocity for your floodway. As I mentioned, you still have to look at that equitable consideration across the borders, and you have to, it's not just your depth times velocity that is driving. You still have to get to that 1 foot rise per the regulations. But this applied approach can give you a starting point. So you're not starting, so far off from what your ultimate D times V might actually be. And then we also supported HEC with the development of the floodway tool in RAS, as well as we're finding them to do some research for GPU processing speed enhancements. So trying to get the speed of the model runs much faster so that it saves that time, and as a byproduct, the cost for the model runs. And then I also mentioned, sort of thinking beyond our current regulations. We asked the group to take a look at, what kind of potential option might there be for a floodway alternative if we didn't have the regulations that we had today. And we just sort of gave folks carte blanche to think outside the box and tell us, what would you see as the most critical thing and most critical component related to a floodway. And so we got 4 different scenarios that were shared. One looking at kind of criticality zones based on the conveyance, where they looked at depth times velocity and the annual exceedance probabilities to try to understand these critical zones for conveyance and load development in those areas that were less critical. There's a graduated hazard zones based on using some of the Australian Disaster Resilience Handbook and their flood hazard charts and looking at allowable development related to those. There was a community-driven selection that was identified, and then also one scenario that similarly used depth times velocity and had it broken down into pieces that might be static, that you would say these don't change, and then sort of a live floodway whereby you would need to look at evaluations for different alternative development within that sort of live area. So none of these, just to be clear, none of these have been recommended per se by FEMA as a path forward. They were provided by the team to say, here's some ideas as we were trying to think outside the box and think what could be possible and useful as a floodway going forward. So, but all of those are listed in the, I'm going to go ahead to the reports. All of those are listed in the reports that we have out. So all those different alternative reports are posted and they're available if you reach out to us via the group. There's also the applied approach, as I mentioned, which is out on our SharePoint site if you're doing those studies and you work with FEMA on those. And then the 2D floodway exploration testing results I mentioned, looking at steady versus unsteady. I looked at surcharges. We looked at surcharge calculations with all cells versus that evaluation line, which led us to the viability of the evaluation line approach. And then that raised terrain versus high end value. And then lastly, with floodways, some of the remaining topics that have been brought up, as you can see, there's still quite a few things that folks are struggling with. And so as we've accomplished a lot and got a lot of things in line and moving forward, we also still have some things that need to be worked out. So appropriateness and conditions potentially for removing floodways if they don't make sense technically, low Mars and no rises, how to really work those in and make sure that they're usable when we produce them, managing the tie-ins, urban areas, the overflows in the street areas, how depth times velocity can help with the initial delineation, and then alternatives to floodway development that might still meet regulations to make those easier, separating out the floodway from basin scale models, communicating floodways. It's really challenging. Floodways on braided streams, a lot of these kind of tie back to some of the same challenges. There really hasn't been a deep dive into really whether steady versus unsteady is a quote better option and what the implications of that are. So trying to look a little bit more into that. And then options for modeling the fringe. Building on some of that initial testing that was done related to understanding high end values versus fill placement, which is artificial fill placement, which is used to squeeze a floodway into being. And so still quite a few things that we're working on. So I'll say this as a plug before we move on for all of these groups. If any of these topics are interesting to you, the group definitely could use more folks to be a part of it. So reach out and we can get you hooked up where you want to be for that. So with that, I'm going to turn it back over to Dave to talk about some of the other groups.
Yep. Thank you, Laura. Before I talk about this slide, just to recap, like where we have been and where we're going, right? So the floodway IPT, the integrated project team, was initially developed to help solution issues that are arising from developing floodways in 2D models. The HEC-RAS model specifically is what we have been focused on. A couple of years ago, we kind of took a step back and said, there are other issues, there's other questions associated with 2D modeling, flood modeling, apart from just how do you make a floodway? And so about 2 years ago, we decided to kick off several other subgroups, which I'll go through now, and we'll talk about kind of where they've landed and the progress they've made. That being said, floodways has been in existence longer, so they certainly have made some more progress and some more testing to solution some of the things that they identified. And all of these subgroups are they're volunteer basically. They include folks from FEMA headquarters, from FEMA regions. They include people from CTPs and states, members of state Department of Transportation agencies. All these members kind of have self-identified and volunteered to be part of individual subgroups. And so Before we went too far into all these other subgroups, we started off a foundational subgroup to basically lay out the assumptions and start the gives a little bit of Jersey barriers for where the other subgroups should head, and try to understand like where we could find easy wins, and also understanding and putting into context, there's a current state, there's probably an interim state, and then there's going to be a future state of how we do flood modeling and how we solution these things. So some of the highlights that came out of the foundational assumptions subgroup of the 2D integrated project team was this idea of a full watershed analysis, trying to move away from creating disposable models or recreating models over and over, creating a single watershed per model, so you don't have independent reaches. This can help us understand both the fluvial and pluvial aspects of flooding. Also, this idea of having different levels of detail within a 2D watershed model, so you don't have to have an entire model that has 50-foot cell sizes everywhere, just because it's computationally burdensome, and you don't need that sort of resolution or that computational power everywhere. And so defining guidance for having different levels of model size or cell size resolution where needed, and better understanding what it means to be a living model, and how do you update a model? What does it mean to update a model versus update a regulatory map? How do things like letter of map changes play into this, and really starting to consider moving towards the cloud, hosting these models on the cloud, allowing folks to check out a model, enhance that model to improve it, or to answer the questions that they think are necessary, but really having that base foundational watershed model up there and easily accessible. Next slide. Skip the slide. So this is an example of that one thing I mentioned about having variable levels of detail within a single watershed. And so this is in the context of BLE and the different options in BLE, and just showing that, in a large watershed model, larger cell size are going to be fine some places, and they'll allow you to route the flows towards places that are more urbanized, or that you're more that you want to have more detailed mapping and results. And so in those areas, you can increase the cell size in those areas, but overall you have a larger watershed model that has variable levels of detail within it. Next slide. And this was one of the outputs of the foundational assumptions, or the foundational subgroup. So this left-hand picture is really trying to communicate the value of 2D modeling, both in a regulatory sense and in the aspect of producing more comprehensive data, like I was talking about in the Future Flood Risk Data Initiative. And so 2D modeling can be the foundation for both, and has value in both. And on the top hand graphic, and I apologize, this is a little bit of a busy slide, but it gets to this idea of like where we are in the current state versus going to the future state. So on the top hand graphic, that's blue and green, is kind of where we are in the current state. So if you're going to be doing modeling or making a regulatory map, you start with your data collection, and then you could either choose, you typically would choose a 2D or a 1D approach. Then you do deterministic modeling for your regulatory purposes. This facilitates things like appeals and letter of map changes, and you produce regulatory data, and sometimes you produce some advisory data there. And then in that green part, right, we can also leverage 2D meshes in the future flood risk data workflow, which is still in development, and Laura mentioned the Army Corps of Engineer pilots that we're doing with the Army Corps of Engineers to really build out the methodology for this probabilistic approach, but leveraging 2D models to produce a probabilistic graduated data set. In the future, which is the future condition, the future state is this bottom area that has the pointer on it now, where you start with your data collection again. You do your 2D mesh development, you run your probabilistic analysis, you get that wide broad, comprehensive data set of flood hazard and flood risk in your entire watershed. And then you can downscale or optimize that information to pull out the ones that you think are important to you. Is it the median 1% annual chance flood? Is there some uncertainty associated with that? Perhaps you want to refine your mesh a little bit. Maybe you want more detail than that original base model had. So leveraging the ability to enhance those models to get them to a regulatory product. But it's still, we're not just focused on producing the regulatory product. That is one derivative data set that gets derived from this 2D base modeling approach. Next slide. Okay, so now I'm going to transition to the hydrology subgroup. So the hydrology subgroup kicked off in 2022, and they identified and had some really productive conversations around hydrology. And it's not necessarily just about 2D modeling, it's hydrology in general and how we treat hydrology in FEMA modeling and mapping. And some of the issues that we identified, I say we because I co-led the hydrology subgroup. Some of the issues we identified is that there's multiple ways to account for hydrology. There's different ways to produce stream flows within these models. Some of them produce fluvial, some of them produce fluvial and pluvial, and all of them have their strengths and limitations, and trying to tease out what those strengths and limitations are so that you can make informed decisions. Other issues was a need for guidance on things like hydrologic distributions and durations. And so this is really talking about if you have a 2D model and you're doing rain on mesh, what is the source of precipitation that you're using? How are you distributing that precipitation into a time series that you can put into your model? Also defining guidance for things like scaling of multiple inflows. So if you're looking at discrete stream time series in your model, how are you timing those within different tributaries? Guidance, identifying need for more validation and guidance on validating and calibrating, comparing to observed data sets and the tolerances associated with those, as well as some issues identified with appropriately accounting for watershed storage and regulation. I won't talk a lot about this, but just overall, some of the outcomes and paths that we identified. So the future flood risk data standard operating procedures should resolve some of these issues, basically just because of the modeling approach that it's taking and the more comprehensive approach that it's taking. But we also identify the need for updated guidance and standards. We also flagged that there's this separate Army Corps of Engineer effort that is going to be kicking off soon that is aimed at improving the way that you leverage design storms within a 2D framework, and really pointing to that as a source of information and something that we could perhaps incorporate into our guidance and standards. And yeah, often some of these are looking towards the future and some of the standard operating procedures that we can develop to better improve the representation of hydrology in our modeling. Next slide. One thing that we really did leverage and use was, and this actually came, I believe, from the products subgroup, but I think this is a really useful conceptual understanding of the different ways that you can treat or model hydrology within our current framework. So on the top left is a RAS only approach, right? So you're using, if you're dropping rainfall in your model, you're only using HEC-RAS. You're relying on the somewhat limited capabilities of RAS to account for hydrological losses, but you're producing pluvial and fluvial results, and you're just relying on one model. And so those are some strengths. On the top right is the modeling approach that we're actually leveraging in the future flood risk data, where we're coupling HMS, HEC-HMS, which is a hydrology model. We're coupling that to HEC-RAS, so we're dropping the initial rainfall in a hydrological model, more comprehensively accounting for hydrological processes, then exporting the stream flow and the excess precipitation into HEC-RAS to produce both pluvial and fluvial flooding. And the bottom two approaches are just two different ways really of of deriving discrete riverine flows that you can then route through a two-dimensional model. So in this, you're not really leveraging the full capabilities of 2D because you're not producing pluvial results. But some of the strengths of these is that, you know, it's more conducive to things like regulatory considerations. So it's easier to do a no-rise if you have a stream flow time series routing through your model, and you don't really have to worry about the precipitation or the pluvial flooding occurring. And so we spent some time just quantifying the various strengths, limitations, and applications of these various approaches to modeling and incorporating hydrology and hydraulics together. Next slide. So some of the outputs from the hydrology subgroup, we have a summary of rain on mesh options, which I just presented there, and we have draft hydrology recommendations towards FEMA that identify the issues, technical challenges, and potential options moving forward. Next slide. So I've done foundations and I did hydrology. So another subgroup that occurred was the mapping subgroup. So this kicked off in November 2022. And several of the issues that the mapping subgroup identified were things like map rendering, what the algorithms that you use for map rendering, the methods, the consistency or inconsistency that some of these methods have inherent to them. Also, identifying the need to establish pluvial mapping thresholds. So if you're going to map pluvial, you know, like urbanized or flooding from intense rainstorms that's not associated with a stream, what's the threshold that you show that on a map? They also identified issues with our current digital viewers and the needs for upgrades and the needs for, you know, better hosting raster data and being able to just do things like point and click on raster data and get the information behind them. Identifying needs for updating the firm database, for map cleanup, and also just noting some of the limitations of deterministic mapping within a 2D element or a 2D model and the uncertainty that can be overlooked. Some of their outcomes and paths to completion they've recommended various testing and or guidance and standards updates. They also recommended to FEMA, you know, to better evaluate the timing of potential IT investments, because a lot of like mapping and the ability to share flood hazard information and the mapping behind it revolves around improving the IT infrastructure that we have. And also looking to some other testing to address some of these other questions. So next slide. So the mapping output that we have is the 2023 mapping recommendations. So we have a summary report where they documented the issues and challenges and outlined some potential options that the group had discussed within their subgroup. Okay, so products was another subgroup, and this is going to be 2 slides, so bear with me. Products had several issues they identified. Really, you know, if you're building these 2D models and you're building these large models, you know, really having a system to track and download and upload those models are necessary. Really improving the way that, or suggesting improvements to things like the firm database or the FIS report about storing and rendering different types of data and whether or not it's for regulatory purpose or other purposes. And some of their outcomes is, you know, identifying IT investments that could improve things. Also identifying this concept of firm 2.0. So what can a new firm look like? One that leverages 2D modeling and we're not trying to shoehorn 2D information into a 1D centric firm, and really kind of pushing that idea of you know, revising the way that we produce flood insurance rate maps as a product was a recommendation. Next slide. A few other issues they identified, you know, things like data tables and how do you summarize regulatory flows within the FIS report, and whether or not that is really a how applicable that is to the 2D modeling, or how do you extract that information from the 2D modeling? How do we do mapping revisions in a 2D ecosystem? And really, one of the main things was building buy-in and acceptance of 1D versus 2D to stakeholders. Again, a lot of their outcomes or paths focused on really trying to rethink the way that we produce firms. What do we require to be shown in firms? What should we or could we require or not require in an FIS report? What's helpful in an FIS report? What could be even more helpful in an FIS report based on the more comprehensive data that 2D modeling tends to produce. They also spent a little bit of time, kind of thinking about non-regulatory products, because we'll be producing a lot of other data. 2D just by itself produces a lot of data. A lot of that data is useful, but it's not necessarily that regulatory line on a map. And so trying to kind of, parse out how do we think about these things, and how can we best produce and deliver that sort of information. Next slide. So they have a draft recommendations report that came out late last year. Again, it's a summary of documenting issues, the technical challenges and options, and we're waiting to identify the types of testing and sort of the IT sort of infrastructure investments that would be required to maybe meet some of their recommendations. So the regulating subgroup that just it kicked off in January 2023. It's really just getting going right now. They're building steam. They are formed to gather input and address regulatory challenges associated with 2D methods and products. So this subgroup is coordinating closely with other subgroups to review their recommendations, what their issues were, and really kind of establish that pipeline of, here's what hydrology found out as an issue, here's what mapping, here's what products found as an issue. What can we think about in the regulatory subgroup to really address these issues? Focusing on compliance to ensure that we're meeting the provisions of the National Flood Insurance Program, and also working to collect feedback from participants about usability of products, higher local standards, potential training needs. So again, another plug, if you're interested in any of these things, please reach out to Laura and I, and you can get involved in some of these subgroups. And we expect them to be delivering their findings, hopefully later this year. We'll see. Again, the regulatory subgroup, they're focused on three main issues. One is future regulatory changes and future products. So, what could future products and product enhancements, what sorts of enhancements would be useful for things like planning, mitigation, identification of risk? How can future products make communities more resilient? They're also looking at product usability, so reviewing recommendations for usability within current regulations and applied approaches, and evaluating improvements to future products. And finally, local ordinance updates and community adaptability. And so really trying to think critically about, based on other subgroup recommendations, like the product subgroup, what are the guidance or changes necessary for local floodplain ordinances, reviewing the ability of a community to adapt to future map changes, digital products, the use of graduated risk. So, how can communities better be prepared and leverage this enhanced data and its delivery? And finally, evaluating the impact of communities as products and 2D derived products become available in the future. So there's a couple. They're phasing this in a couple ways. So they're looking at the application of products in phase one. So how will future products address current barriers and limitations? How can future products be more usable? What problems are future products trying to solve? What's the community's ability to apply that solution? Having that data is available is one thing. Being able to apply it and make decisions and implement it is another thing. And so what tools would be needed to help this information be successfully applied? And then in phase 2, they'll be looking at regulatory changes. So what changes should be considered to local floodplain ordinances? What changes should be considered to federal code? What about higher standards? How can we leverage 2D information to inform higher standards? Can ordinances include adoption of digital spatial data? And what are the challenges for a community to adopt, map changes in this future world? So really easy things that will be easily solved. I kid, of course. They're really thorny issues, but they're tackling them, and they're getting feedback and really trying to think critically about some of this stuff to help inform and make recommendations as we move forward. So the hydraulic subgroup that just kicked off in 2024. So some of these subgroups are kind of moving in parallel just because it would otherwise take years and years and years. And oftentimes some people in one subgroup also are in another subgroup because of their interests or expertise. And so we're trying to stage these, but sometimes they're running in parallel. So they're working, hydraulics is still working on defining their primary objective and purpose. They're leveraging some of the results from the foundational subgroup about living watersheds and multiple levels of detail within a single watershed. Currently, the subgroup has over 60 members that, as I mentioned earlier, right, these are diverse subgroups and diverse members of headquarters, regions, states, regional, local CTPs, LOMAR review partners, and state, federal DOTs, as well as private sector and people who kind of make these maps or do this mapping as their job as a consultant. So some of their ongoing activities is they're developing their subgroup charter. They're going to be setting up a kickoff with subgroup members, and they'll be surveying the members about what they view as the challenges or issues around hydraulic modeling as in context of 2D, two-dimensional modeling. And then they'll also be gathering and going through the recommendations that have already been made within those reports that I kind of mentioned on screen, from the recommendations from the hydrology group, the mapping group, and the products group. Next slide. Oh, and with that, I think we have a little bit of time for questions. Thank you a lot. I hope this was informative. I don't know, Lori, anything else you want to add?
No.
All right, great. David, Laura, thank you very much. There was, wow, there was certainly a lot of great information there, and we do have quite a few questions. So, if you don't mind, yeah, I'd like to get into a little bit of Q&A. I'm going to do my best. Some of these came in from different parts of the presentation, some of them fairly early. So I'm going to try to make sense of this and do this in the best order I can. But bear with me, everybody, please. So
And Kevin, this is Alan.
yeah,
Maybe
please.
you got that poll question you want to post.
Okay, yeah, we'll do that first. Yeah, that's a good idea. So we do have a quiz that we wanted to test you all on. So let me open that up. And it's about a part of the presentation from earlier. So the question is, which one of these is not a recent change to the floodway standard? And there you go, A, B, and C. We'll give you a few moments to consider that and respond, and then we'll take a look at the results.
And then while you're doing that, I guess I have this is Alan. I have a basic question. I participated in the, first of all, this is quite a fire hose you threw at us here. And even being on some of these ITP subgroups, I'm trying to absorb it. But the one basic question I have about floodways is, the cumulative impacts of floodways is how the standards were established for floodways, where they tried to limit the impact of development encroachments into the floodplain by limiting that those increases could be limited to 1 foot. So it's basically a cumulative impact analysis. And so I've been participating in the floodway subgroup for a while, and one of the basic questions I always have is, how does this address the cumulative impacts? Because many of them are focused on depth velocity and looking at more risk. How is the cumulative impacts of encroachments into the floodplain going to be limited to that 1 foot? And in many cases, many states request that those impacts be much less. So how are you going to address the cumulative impact analysis?
Yeah, so a lot of the depth times velocity tools, like the applied approach and some of the things that we're providing are to give you a starting point, because understanding that where those depths and flows are the highest and velocities are the highest is typically where that floodway is going to be, because that's the main corridor of that flooding source. But ultimately, the regulations are still applicable, and so as they may use that depth and times velocity information as a starting point, but they ultimately have to still be able to show that the change hasn't occurred to the floodway beyond that 1 foot. And if there is any change, any impact beyond 0 along those evaluation lines in a 2D space, then they would still need to do a letter of map revision. So then your starting point for the next evaluation is already inclusive of that change that's occurred. So similar to the way that it's currently done today, that's how that sort of cumulative piece comes into play, as that if you do anything outside of no impact to that area, then it has to be provided as a letter of map revision to FEMA. So that changes the starting point.
All right.
Okay, Kevin, you want to show the results of the poll?
Yeah. Thank you, Laura. Let's take a look at the correct answer here. And so that was C. Profiles must be produced for 1D and 2D studies. So there you go. And I will stop sharing that.
So how did people respond? Did they get this one? Can you give the statistics on this?
Yeah. I would say about 70% of people got it correct. So that's great. And I'll stop sharing that. And so with that, we'll get into a little bit of Q&A here. Again, it's a little bit all over the place, but I'm going to try my best to kind of curate these here. So right off the bat, Joanna's just asking, which IPT subgroups need more members?
Well, I think
So do they all, or how many members are in each, or
I mentioned, so the hydraulics subgroup currently has 60 members. I forget how many the regulating subgroup has, but I mean, I think if anyone is encouraged, or I would encourage you all to join the ones that are still going on for sure. And what happens in these subgroups is, right, we have a lot of people, but there's fewer people that are active or constantly participating or providing input. And so we really do value voices that have ideas, have thoughts, have contradicting ideas. It's all welcomed. And so if you're interested in joining, please reach out.
yeah,
Yeah, I
great.
think the key is to be more engaged with a topic that you're passionate about, right? Like one of the components that you feel more tied to. And a lot of these subgroups we are breaking up into, what are we calling them, micro groups, Dave? So like, as you saw, like the floodway has 13 more topics. Like if we tried to tackle those one at a time, it would take us forever. And so because we have the larger the pool we have to sort of draw on for those subgroups, the more we can sort of break some of those pieces up into micro groups, subgroups, as they start to look at pieces and then bring it back to the subgroup, and start to discuss some of those potential solutions. So we get more ideas and more feedback and more potential solutions. So
Wonderful. Yeah, that makes a lot of sense. Thanks. So Tyler had a comment as well as a question. Tyler says, our experience has been that many community floodplain administrators struggle to interpret and effectively regulate current 1D floodplains. It seems that 2D modeling and a probabilistic approach to regulating floodplains could be very overwhelming to many floodplain administrators. will there be a significant focus on training and education as 2D regulation rolls out into the future?
So I'll start and then I'll let Dave jump in because I know he's got thoughts on FFRD. So not all of the probabilistic data outputs at this point are at a point that they could be rolled into a regulatory product, right? So there would have to be a lot more conversation and discussion about how we take those probabilistic outputs and turn them into something that meets the regulations as they exist today. And or if the regulations were to change over time, how that would play in. So assuming that there is a change to that in how we are developing that 1% and putting it on a flood insurance rate map, there definitely would be there would have to be I think one of the subgroups talked about change management and as well as training curriculums that needed to be developed in order to help support that. We also understand that just having this additional data in addition to what's on the flood insurance rate map requires some education as well, right? For folks to understand why is the information on the flood insurance rate map different than what might be provided through FFRD or other base level engineering studies that a community might develop. And kind of gets back to sort of, I would say, the first slide Dave had, which is, the regulatory flood insurance rate map is like one snapshot in time based on historic data only. And so there's an interpretation that that's the end all be all of data when we know as practitioners that it's not, that there could be storms greater than that it's not inclusive of all potential storm sets that could occur. And so some of that gets to the messaging as well. But Dave, I don't know if you have anything to add.
I mean, I think that I agree with all that. I would maybe just say, right, a 1% annual chance floodplain produced by a 2D model versus a 1D model, if not all else being equal, produced right today, you would have the same challenges regulating to either of those, right? It's that line on a map, and you're trying to use that information that you have to make a decision about a local town's application to build a shed or something like that. I think where we're trying to go with like the 2D products and the 2D mapping is understanding that even though a 2D model or the modeling methodology might be more complicated behind the scenes, it can produce more easily interpretable information for you to make decisions. And so how can you leverage that information? Maybe it's in the digital map view, or maybe it's in other representations of the data to facilitate decision making.
Okay, great.
Kevin, I've got one
Alan.
question I was going to ask, and that
Yeah, of course.
was that Carl asked this question, and I think it's a good question. Is this software, I mean, the FFRD, is this similar to the software that's used for the risk rating 2.0 insurance pricing?
So I don't know that the question is particularly aligned. So the short answer would be no. The software is completely different. The software that we are using for doing hydrology and hydraulics is the HEC RAS model software. And then however they determine the insurance rating is through some other economist calculation of statistics in order to do all of that. The data that we have, so like on the base level, I mean, we're talking about two different things. This is hydrology and hydraulics modeling is what we're talking about, not insurance rating per se.
Okay.
So that was the intent of the question.
Yeah, that's a good distinction. Thank you, Laura. So along those lines, you had mentioned HEC RAS, that software, and we actually had a question from Stephanie about that, wondering, with other 2D software out there and usable like Flow2D, SRH2D, and others, do you find use for that, or do you not use that at all in the context of your work here?
I can chime in. So I guess, as we mentioned, right, there's various members of these integrated project team subgroups. A lot of them are DOTs that use Flow2D or other hydraulic software models. A lot of the questions that we're kind of trying to deal with, I think, are model agnostic, and those stakeholders that certainly provide their feedback about like kind of their views of things. There are certainly some RAS specific questions that people are dealing with, like specifically like the RAS mapping algorithm, right? That's a good example of something. But broadly speaking, the 2D IPT is more is less about a specific model and just more about the larger kind of construct of 2D modeling. And we recognize that there's a variety of models that are used within this within this ecosystem.
Yeah, yeah. Very good. Thank you, David. So I've got a couple of questions here. I think they're related enough that I'm going to try to kind of batch them together, and hopefully it'll make sense. But so Jill asked, is there a sense of when this type of analysis would be required as opposed to being something that's allowed by the NFIP? So that's question number one. And then question two from Craig is the regulatory approach limited to updating GNS, guidance, etc., or are CFR changes coming down the road? And if so, when might these be anticipated?
So, so there's not really as required versus allowed, right? So,
Yeah.
we can I think there is flexibility within the regulations for the 1%. To say you could do these types of methodologies today. Somebody could do a probabilistic analysis and come up with a 1% annual chance event, and that's completely within the realm of the regulations as they exist today. I think before FEMA did anything like that, there would have to be quite a bit of outreach if we're changing sort of our overarching expectation of how those models are done, because all of the guidance and standards today currently talks about 24-hour storms and things like that, right? So there would be extensive engagement and outreach before we said that we would be only using a quote probabilistic approach, I think, to a flood insurance rate map product. As far as the regulatory approach is limited to what is in the change. So we have the ability to change the guidelines and standards, right? So we could say we want to do that, right? And we could say we want to do a different 1%. But that would be changeable with changes to the guides and standards, as well as outreach to the stakeholder community. CFR changes would be a much greater thing. The only thing that I could say to CFR changes is that I know there was a notice, what was it called? A request RFI that was sent out maybe, I don't know, maybe Alan, you or Kevin know better, 8 months ago, maybe, from floodplain management, talking about what kinds of changes they would like to see to CFR. All I know is that RFI went out, right, and that they're looking at the responses from that RFI. As a general layperson, CFR changes take a long time. Regulation changes take a long time. Even if there was concurrence and everything worked as smooth as possible, you're talking probably several years. And that's assuming things are perfect and everybody agrees on a path forward, right? So I don't know that would be the case if we were changing floodplain management regulations, but I don't know. I don't have any sort of insider baseball on that. So it's just I know that RFI went out. That's public knowledge. There were responses. So there's the possibility, but timing wise, I don't know where that would be.
Yeah, very good. Thanks, Laura. It was my sense as well when I was reading the question, change to CFR. It seems like it might be an unknown in the future, but I just wanted to ask just in case. So moving along, we've got several more questions, and again, I'm trying to curate these. Alan, if you see any in there that you think are particularly noteworthy and you want to make sure get asked, please interject. But in the meantime, we got a question from Tim asking, how will this factor into map maintenance funding nationally or within the region for communities that have 1D and want to update with more recent data set under 2D?
So what I would say is, as we're looking at sequencing sort of this shift to FFRD, methodologies is there's a need to meet the current requirements and current regulations to ensure folks have updated flood insurance rate maps, right? But there's also that balance with trying to start to build the base level of those data sets for FFRD going forward. And those are looked at a much larger HUC 8, HUC 4 watershed, Dave? HUC 4 for hydrology, right? And then maybe HUC 8 for hydraulics. So a larger scale watershed. So we're looking for consistency and the ability to produce these data sets across the nation. So what the problem we have today, right, is that we have some data here and some data here and some data here. And the idea, one of the underlying ideas behind FFRD is to be able to have a broad brush of data across all of the watersheds. So we're trying to look at that in a strategic way as to how we could roll that out. So there will be some give and take there as we start to build that underlying data, as well as still meeting the needs of the communities today to produce those flood insurance rate maps that they need for regulation.
I do have one question here, Kevin. I think this is a good one. This is from an anonymous attendee. Says a lot of communities have concerns that, well, first of all, I'll state that one of the big advantages of 2D modeling is it's a much kind of more precise representation of the impacts of encroachments. But the question is, a lot of local communities have concerns that the 2D floodway is much wider than 1D, thus preventing future or further development. Has FEMA done any testing on 1D floodways versus 2D and developed any guidance on that?
We've done some initial testing, not on that particular topic per se, but some of the outcomes that we found from just looking at 2D floodway testing in general. If you have a semi-steep, nice streamline, normal 1D acting watershed, the floodway and the modeling come out pretty similar. You really start to see the differences in those floodways when you have the more super flat areas where it's allowed to spread out, or braided streams or things like that the 1D modeling just didn't handle very well. And so you see very similar answers in sort of the traditional one-dimensional environments, the environments that behave in a very one-dimensional way. But you start to see those differences in the two-dimensional spaces where you've got those flatter terrains and things like that. So does that mean one is performing better than the other? It may be that the two-dimensional is being able to understand those nuances as the flows go in and out and move upstream and downstream and side to side that the one-dimensional couldn't do, and provide a bit better answer for that. But we also did, as I mentioned earlier, implemented the evaluation line to try to give some concession to the fact that it's not completely in line, because there's just so many more data points than there were initially when the regulations were written, and the intent of those regulations to try to give a little bit of flexibility to communities to help understand that in a more generalized fashion, so you don't get some flashes that kind of mess up your model here and there at one cell or something. But we haven't done any larger testing of like as a whole to try to compare the two. Dave, I don't know if you know of any other testing.
I don't know of any other testing. I would just add that right, part of the work that the floodway subgroup is doing is considering and evaluating potential alternatives to modeling the floodway. So right, Alan, you're talking about if I take my 1D construct of a floodway and I try to shoehorn it into the 2D model, like there's questions that arise, right? One of the things we're working on is how can we better leverage 2D data to maybe consider or evaluate alternative ways of developing floodways that better leverage and really use the 2D information for what it's worth.
So this is Alan. One comment about that is that floodways in general are a bad construct because it allows development in the floodplain, and 2D modeling just does a much better representation of those impacts and that's why flood damages have continued to increase, because we're still continuing to develop in the floodplain. One other question here from Karen. The complexity of 2D modeling makes it less usable for the public. Even in the engineering community, the 2D work is complex and requires large computer hardware investment. And then a statement here at the end is that the 1D method is preferable IMO, which I'm not sure what IMO stands for, but
in my opinion.
oh, in my opinion,
There
we
you go. Yeah.
And so that is one of the issues in the engineering community, is that there's not a lot of engineers that understand 1D modeling, and now you add the 2D approach, that even a fewer number of engineers are going to really be capable of doing this. What's your comment on that?
So I'll start. I feel like I'm jumping in front of you, Dave. So jump in anytime you want. So I would say, if you go to the generic homeowner in any one of these communities, they don't understand the one-dimensional modeling either. So I think there's a lot to be said for the fact that the complexity of one-dimensional versus two-dimensional is really, it's not exponentially different for a general stakeholder. The mapping and modeling community, I think there are those engineers that have been around for a while and have been doing 1D for a really long time. And anytime you start to shift to a new methodology in anything, even, software changes, ArcGIS changed to ArcPro, right? Like everybody's like, oh my gosh, it's so different. It takes a little bit of time, but people are learning. I think I see more and more 2D models. I should say, more and more from different communities, two-dimensional models being used much more frequently. We ran into similar challenges when we switched. I want to go really old school on you guys now. When we switched from NGVD 29 to NAVD 88 on the maps, there was a huge uproar. People said the surveyor community can't handle NAVD 88. They don't know what to do with it. It takes them too much time. It's more work. But ultimately, once that information was published on the firms in that NAVD 88, it really got folks invested in trying to learn that new methodology. And now, of course, nobody would even think about going back to 29, but of course, we're about to get a new datum too, which I don't want to talk about, but that may change again, and we're going to be in a similar boat. But I think there's something to be said for when the changes occur, we don't want to ignore the ability to do better things and provide better products, because there's a subset that doesn't potentially, that hasn't worked with it yet and just needs to be brought up to speed to work with it. And I think that is happening. I see it in the last 2 to 4 years. It's dramatically, I've seen like the number of questions that pop up related to 1D versus 2D are just a good bit different. So I think the key really is making the products, like Dave mentioned earlier, making the outputs and what we can provide to the communities as simple as possible. The information behind it is complex. It's always going to be complex, whether it's 1D or 2D, and we need to really make what we provide to them to implement as simple as possible, and how they can implement it as simple as possible, so that that really is where the heartburn is. They ultimately don't want to learn two-dimensional modeling, or one-dimensional modeling. They want to be able to more simply implement their program and understand what it means and how to use it.
Great. Thank you, Laura and David, for providing those answers. So we're just about out of time here. I know we do have quite a few questions left open. I would say the balance of most of those being, how can I get involved, or where do I find a link that was referenced, or a report that was indicated early on. So we'll follow up with you all after the fact as to where you can get that information, and who you can reach out to and so forth. But in the meantime, please give us a rating for our presentation today. And as you're considering that, I just wanted to make a couple final comments. Mentioned this at the top, but one more time: continuing education credits. If you're a CFM who stuck with us for the full duration today, you'll be eligible to earn credit, um, and we'll apply that to your record automatically. It's going to take us about a week, and we'll also be sending out a certificate of attendance on that timeline as well. And that's going to include a link to the slides from today and any other promise follow up we kind of made during the presentation. Last note again, this is a CTP quarterly series. So if you have any feedback or suggestions going forward, please reach out to Alan and we'll make sure to consider that. But um, that's it for us today. So thank you again, Laura. Thank you very much, David and Alan, for helping us out here. And thanks to you all for attending. We hope you have a great afternoon, and we'll see you next time.